Great. And it looks like we're also waiting for Paulina to join us on the stage. Great. All right, thanks everyone. So I will take over for Valeria and Elena, who will be leading this panel. So maybe if we could have each of you give an introduction, talk about your background, and yeah, maybe how that relates to this topic of this panel, which is current trends and emerging polymer AM technologies. So maybe Sona, we'll have you start.
Yeah, hi, that's perfect. I'm assuming you can hear me perfectly fine, right? Go. Awesome. I am going to quickly share my screen as we've all just prepared a couple of slides to help introduce ourselves and how we relate to this content. So just a moment. Which screen can you see? Can you see the background, or can you see the or the correct screen?
This looks correct.
Okay, perfect. Sorry, I couldn't tell from my vantage point. So yeah, hi everyone. My name is Sona Didania. I'm a technology analyst focusing on 3D printing at ID Tech X. Quite briefly, I study 3D printing from all aspects. So when we're talking about the technical aspects, the material side, the market and economic side, I look at it all as part of my work at ID Tech X. I'm originally from the States. I now live in London. ID Tech X is a British company that does market research on a variety of emerging technologies, one of which is 3D printing. And so just very briefly, some things I thought would be good for everyone to know is that first off, my company is hiring. We're looking at analysts, sales peoples, HR persons, and other things. So check out our website if you're interested. And additionally, we're sort of starting up a London chapter of Women in 3D Printing. So if you're in the London-ish area, feel free to just get in contact with me so I can get you incorporated into that. Moving on to the topic of today, emerging polymer AM technologies and current trends. So I think many people will have heard or are familiar with the many different sort of established polymer 3D printing technologies out there in the world. What's awesome about each of these technologies is that they can clearly serve different applications because of their different factors and aspects, different performance parameters, different materials compatibilities, so on and so forth. Still, we're not at a point where any of these individually are perfect as is. There's a lot of improvements that can be made to each of them, which I don't have the time to go over individually. But with that in mind, there are many companies, especially startups, who are looking to improve upon the deficiencies of current established polymer 3D printing technologies. This has led to a wealth of emerging technologies coming onto the market. So there's a lot on here, and I can't talk about anything individually because then we would be here all day. But you can see that there's in every single different type of 3D printing technology, there are new innovations coming about. And like I mentioned, mostly from startups and smaller companies who are really looking to push the envelope and challenge what can currently be done by polymer technologies. Additionally, there are plenty of companies who, in addition to taking a more innovative sort of change everything approach, they're looking at more incremental approaches to this field. So for example, out of stereolithography, you have people who are using that in a little bit of a different way to do micro SLA, or using heat to do hot lithography. Same thing with DLP, where you have multiple companies looking at making it higher speed. And so what all of this innovation is doing in the field is really expanding the envelope of available polymer 3D printing technologies for your average end user. As I've mentioned before, every polymer technology has their advantages and their disadvantages. I don't think you'll ever get a technology that is 100% green across the board, which is what this sort of chart is showing, is the comparative performance of different aspects in relation to other polymer technologies. Yeah, you're not going to get anything that's green across the board, but you might get something that is just right for the right applications or the right end user. And I think that's going to be ultimately a net positive for this field. So I'm going to pop off. That's it for me. Thank you for allowing me to introduce myself.
Great, thanks, Sona. Celine, do you want to introduce yourself?
Yeah, for sure. I will try to do the same if it works this time. Wait, apparently. Yeah, that's the way. Perfect. Let me know if you can see it correctly. We'll do it the quick presentation in 3 slides. So what I will be presenting, so I'm Céline Parascon, I'm based in Brussels, and I'm working for additive manufacturing field, let's say, for the last 6 years. I initially started in a service bureau, trying to convince customer in a good way to choose the right technology in the right path. As Sona's mentioned, there are plenty of, and you need to find the right fit, right? So I did that for 3 years, and now I'm working for Solvay, which is a chemical company based in Belgium, but working worldwide, where we are active in different polymers. So really trying to fit or to see the right fit for the polymers from Solvay to the additive manufacturing field. So just to have a quick, sorry, goes too quick. The quick summary of what Solvay is doing. They are involved in the specialty polymer. So if you look at the pyramid, we are really involved on the high performance polymer. That's why I'm working on these materials such as PEEK, PPSU, PVDF, so really harsh environment, a challenging market like oil and gas, medical, or aerospace. And this is a challenging materials also to process in additive manufacturing. So there are steps to go through. And on the next one, just to say, and for me, it's really key and really important, I'm working really on the AM material sides, but there are 3 pillars in additive manufacturing to make a good part, which is having the right equipment, the right processes, the right parameters with your materials, but also having the right design to make the right fit. So Solvay is really involved on the material side. We are developing, it's our core competencies, but we have developed different approach with the partners to look how we make these things together and how we can improve the performance of the part at the end. And finally, yeah, based on that, what I was doing for the last 3 years is qualifying the materials, so helping everyone on the market to understand what is needed for high performance polymer. So I think I have a presentation later on, so you could look at this, or having helps to how to step with high performance polymers in the market. So that's mainly my background there. Thanks for that introduction. I'll let Paulina to present herself.
Thanks, Celine. Paulina, would you like to introduce yourself?
Yes, I would like to. One moment. Ooh, I don't know how to click. Should I click?
You can click the share button and either share your screen or present a document.
Yes, and now can you see my screen or not? I mean, my presentation or not? Oh, it doesn't work. I sent my presentation to Elena, but I don't know, but it doesn't work.
Okay. It looks like you can also send it to this either in a chat to me or to the general chat, and then we can present it if we're able to do that.
I can present it for you. I have it on.
Oh yes, Aline, you have my presentation.
Yes,
Thanks.
no
I don't know
worries.
if something. Sorry for that.
No? No worries. Can you see it now?
Oh yeah, yeah. Thank
Looks
you.
great.
Yeah, thanks. Okay, so my name is Paulina Latko-Dorabek, and I work as an assistant professor in Warsaw University of Technology, but also as a senior researcher in Technology Partners Foundation. And that foundation is a multidisciplinary research and technology organization located in Warsaw, Poland. And we're mainly involved in the R&D projects related to the development of the thermoplastic materials with the new functionalities. Collaboration, not only in Europe, but also, for example, in Canada. So we already realized a lot of projects with the industrial clients. So today I would like to tell you some words about the one type of the emerging materials for the 3D printing that are undoubtedly electrically conductive filaments. Yes, you can go to the next slide. Oh, I cannot see the next one. Oh yeah, okay. So as I told, in the last more than 5 years, I was working with the thermoplastic polymers having conductive properties. And I was trying to transfer them to the industry. However, for some cases and for some specific application, the typical method used for the polymer processing, they failed. Therefore, I saw the opportunity maybe to work with the FDM 3D printing and conductive filaments. So when I did the research on the market, which type of the commercial filaments we have, so mainly I found those based on the standard polymers used for the 3D printing like PLA, ABS, TPU, that are doped with different type of the conductive materials. So the typical application for the conductive filaments, there are sensors, printed electronics, and textiles. And for that application, the typical standard polymers are enough. And also you can see on the graph that the electrical conductivity is not as good, not as high as we required for the high tech application. So for that application, these polymers are okay, but yeah, then you can switch to the next slide. But for the high challenging application, like for example, aerospace, if we're looking for the replacement of the heavy metal parts, and the one idea is to maybe to print the conductive composites instead of metal parts, so that these polymers, these conductive filaments available in the market are not enough. Yeah, so you can go to the next slide. So far, my experience with 3D printing using conductive filaments show a lot of, I don't want to say problems, but the challenges and the issue we need to face if you want to apply the conductive filaments in high-tech application, like for example, in the aerospace. So I summarize here the topics we can discuss, but there is quite a lot of issue in regarding the printing of the conductive filaments. So for example, it's like too low conductivity, low flexibility, low productivity, is very high viscosity when you add especially for example, the carbon nanotubes or the graphene into the polymers. And also, as I mentioned, because for me is the main problem is that they are mainly based on matrix. And also we have a lot of issue in the 3D printing process. So I think there's a lot of opportunities and challenges, and the work that needs to be done to spread the potential of the conductive filaments in the market and in the applications. So yeah, that's all. Thank you.
Great. Thanks so much, Paulina. And thanks to all of you for being here and giving those really great introductions. I'm super excited, number one, to be here supporting you guys on this panel because I personally am not an expert in polymer. So I'm super interested to learn from you guys kind of what some of these emerging technologies in polymer are. I'm wondering if, I guess my first question to ask all of you is, from your opinion, if you could share with the participants what you believe is the next big thing that we can really expect in the field of polymer AM. Paulina, do you want to start?
Of course, yeah. So because I'm looking mainly on the materials. So if we have good filaments with the good properties, we can actually, in my opinion, print everything what we want. So I'm expecting that in the next future, the types of the filaments used for the technologies will be much more broader than they are now. So there will be not only PLA, ABS, TPU, but and also the high-tech polymers that, for example, as Celine said, that is what I'm really interested in. So I'm looking for and expecting the highly conductive PEEK or PE or the PPS with the high conductivity and good printability. So there is a lot of issue that needs to be overcome, for example, like high viscosity. So there's already a lot of research done, for example, to decrease the viscosity of the materials for the 3D printing. But in the case of the conductive filaments, if we add any additional chemicals that will improve printing, in the same time we obtain lower conductivity, because the charge cannot come from the one particles to another. So then we also have the agglomeration of the carbon nanotubes or the graphene. So it's also the other issue. So I'm expecting the highly conductive, with the good printability, and also, for example, for the aerospace. So the materials, the polymers used will be compatible with the materials used to, for example, fabricate the composite for the aerospace. Because when you, for example, the printed, let's say, as I show, for example, the conductive mesh from the polymers, and you want to put it to the composites, that material needs to be compatible with the resin, with the carbon or the glass fibers, and also they need to be compatible with the whole process conditions, because generally companies don't want to change much the materials they use and the process conditions they use. So this is one thing. And the other, of course, is like we are expecting to have sustainable filaments from it's not only PLA, but also this is connected with the polymers. So if the companies that produce polymers, like Solvay, will be able to polymerize the polymers from the bio raw materials or from the recycled materials, it will be perfect. Yeah.
Great. Yeah, that's super interesting. Sona or Celine, do you have any other insights to add?
I can jump on that. Indeed, I think the sustainability will be one of the topics, making sure that the value chain is taken together, even on the product side. Like if you look at the life cycle analysis of a part, like looking for the digital inventory at the end and all these things and all this push, it will be for me the next change. On the technology side, I'm not expecting something massively disruptive, but as Sonat said, like there are some little improvement and little change that makes the things better and that you can see improvement. I'm thinking now, because AM is there for filament extrusion, let's say for 30 years. And for instance, for PEEK materials, we succeed to make like injection molding value in the Z direction, which is something that was not seen before, but the startups coming in the market push the limits and push the boundary to get things better. So for me, that's the next phase. And the big thing, let's say, I will think more on the composition, multi-materials, continuous carbon fiber printed with the parts. That's probably the next stage for the additive manufacturing from my side.
Yeah, so I mean, most of my points also agree with what Paulina and Celine have said. I would like to also sort of emphasize that innovations in the polymer AM side is coming from sort of all angles. And so you will see improvements on a technical end, also materials innovations, also software improvements, improvements in real-time monitoring, and sort of every step taken in each of those fields contributes to the overall quality of polymer AM parts. And so it's hard to pick like one like big thing overarching that will change the field. One thing I have found very interesting, just to like sort of study as a perspective of the analyst, is the sort of field of volumetric additive manufacturing. And I just find it very interesting because it sort of flips on our head what our conception of 3D printing is. So volumetric additive manufacturing is not your classic sort of 2.5D printing that we get in typical AM, which you're printing layer by layer by layer to form one 3D part at the end. What the scientists are doing, typically with photopolymer resins, is printing a part essentially almost all at once. There's a few different technologies being sort of innovated on to create this. But what it does is that instead of printing part layer by layer, you're printing it almost in a volume all at once. And so I find it interesting because A, it completely flips on our head what we think of as 3D printing. B, what it provides in the photopolymer realm is the potential for much higher speeds, less of a concern as in pulling a part sort of layer by layer out of a vat, and also higher surface finish because you're not having those visible layer lines. Now, it's not necessarily a cure-all because resins themselves have their own concerns when you compare them to their thermoplastic counterparts in 3D printing, concerns over toughness, brittleness, concerns over strength. So it's not necessarily like, you know, going to make everything else become obsolete. But it's interesting in the way it's being produced currently in, you know, a couple of different labs. Like, for example, UC Berkeley is doing things with it. There's two startups, Zalo and Readily 3D, that have their own approaches for it. And so it'll be interesting to see how that comes onto the market and maybe switches up the photopolymer field in polymer AM. And also, especially if they're able to do anything novel from a material standpoint, that could also make a big difference in how it sort of changes up the field and competes with existing technologies. Super interesting. Highly recommend people check out some of the articles about the technical approaches they're using for this.
Cool, interesting. Yeah, I think what's really interesting to me that Selena and Sona, you've both touched on is this kind of the small improvements that are being made in the industry and not necessarily one huge new technology that's really going to change the game. And I think there's a lot to be said, and that really shouldn't be underestimated or, you know, having all of these small like improvements to technologies, materials, and things like that. How do you, another thing that you brought up, Sona, and Celine as well, how do you make sure that, let's say, all of these small increments are being really applied to the right technologies, or where the applications that people are using are using the right additive technology? Do you see that as like a big challenge with polymer AM, making sure that these incremental changes that are being like incremental improvements, let's say, people are finding those? Or is there another challenge to let's say new developments in polymer AM?
I guess, I don't know, Celine, if you want to go first, I should go first. I'm not sure.
Yeah, you can.
Thank you. So I think there's like a couple of layers to that. So one of the sort of looking at historically in polymer AM used to be a very closed off field in the sense that every company was doing very much their own thing. And so for anyone approaching the AM field, you were going to go to one of these companies who are doing their own thing. And if there was incremental improvements elsewhere, you weren't going to get it because you were locked into a specific company. I think that culture, luckily, overall is changing when you look at AM as a whole. Collaborations between companies is much more of the norm, especially for your smaller 3D printing companies who are coming up and trying to make sure maybe what they've pioneered is actually making it onto printers so that it actually gets to end users. So I think that culture change is going to go a long way towards making sure that when people improve on 3D printing technologies, that improvements is felt by all end users, not just a very selective subset of end users, first off. And then secondly, in terms of the challenges of making sure a 3D printing technology is matched with the right application. That is difficult in itself because for a lot of your, established technologies, you have to have sort of discussions over, okay, whether or not the design, the volumes, the quality standards that are required meets those things. And then if you're an emerging technology, there's the question of, do people even know you exist? And so from the emerging standpoint, you do have sort of like those movements towards collaboration, particularly on a materials and on a software end, to sort of use those connections to make people aware that your technology might actually be better applicable for what they're doing. I think the other end is also the new approach that a lot of these emerging technologies are using. So the classic approach in terms of getting a 3D printing technology into the world is selling the printer. You sell the printer to your end user and they will figure out what to do with it. Although a bit with help from the 3D printer manufacturer, but still it's the end user who is making parts on that printer. What people are trying to do to make that barrier to entry lower for 3D printing companies is to become a service provider with their own technology. So they keep instead of selling their printer, they're producing parts on their 3D printing technology alone. So no asking companies to make, hundreds of thousands of dollars in investment in 3D printing. It's just, we'll make the parts for you. We'll sell you those parts. And I think what it does is it sort of allows the 3D printing company to make the case that this technology is really suitable for your application. Look, we've made it with our printers ourselves. And also you don't have to buy a printer, invest in the knowledge, invest in the materials that you need to make this happen. So I think there is very much a business approach, different business approaches out there to try and make sure that these new technologies are getting out into the world and getting into the right applications where they have the most benefits.
Yeah, indeed. I will also, jump on that. I mean, I was showing or showcasing the three pillars, right? The materials, the machine, and the software or the design. And I think that's true. You have to collaborate and making partnerships with the materials and so on to have really this all going together. On my side, one of the challenge that I still see, it's really on the design side that sometimes the when you're on the development phase and when you are developing the product, not everyone is aware of what AM is capable of, or they still have the mindset of injection molding, or they still have this. So it's still that path to still push the boundaries, getting new ideas, out of the box ideas, which is not always that straightforward and that easy, but it's really getting error and trials and improving the parts in that way. So that's still a challenge I've seen 3 years ago when I was in the service bureau, and you are frustrated when you get an injection molding part to print. But indeed, there are stuff that can be done to improve. Like I'm also thinking about multi-materials printing that could say, just the material where you need, and the other ones, like you could think about all these things. So that's for me one of the challenges I still have to overcome, or having more and more people aware and trained for AM.
Great, thanks. Paulina, do you have anything to add?
I can add something. Because I really like the graph that Celine show about these three pillars. So it works actually. That system, let's say, works not only in the additive manufacturing. It also works in the other technologies. If you're like the material researcher and you are developing the materials, you need to have a contact with the end user. You need to, or even the early adopters, let's say, firstly. So you need to hear them because they have a lot of requirements. So even for the printing, it's the same. And when you're looking for their requirements, so then you can design the appropriate materials. Because it's a lot of stories. I know that we can develop something in the lab and we think that it's good and somebody wants that. And then in the end, nobody wants it because you cannot, you didn't prove all of the requirements they have. And also for them printing is that the low productivity is still the case. Cannot print the materials, for example, for the conductive filaments. You can print the small object, the small shape. But if you need, for example, the big panel for the aerospace, and you need to print something, for example, on that, because it's also some type of the approach, and your filament, for example, break during printing because you have a lot of fillers inside, or for example, it's just clog the nozzle because these materials decompose very quickly and they just clog so this is frustrating, and therefore it needs to take do 1 or 2 steps back to work mostly on the filament and the materials structure. But still, cooperation with the industry, it's super important if you want to design and you don't want to put so much effort without good result in the end. So yeah, that's all.
Yeah. That makes sense. Also, I mean, yeah, it's so interesting to hear from my background in metal additive and seeing, a lot of the same issues are the same. I mean, having, understanding what the industry requirements are for different technologies or materials. It's also really interesting hearing or kind of seeing some of these new business models for new technology developers is also kind of interesting to see where that will go in the next few years. I wanted to pivot now and ask a question that came up in the Q&As. This is a question about specifically applications of high performance AM materials in the automotive industries. Do you see, or are there any case studies or example applications using polymers that any of you can share?
I can't share any typical example because of the project, but let's say in general the automotive market is pretty high volume and high price pressure. So it tends to see that when you use AM for high performance, maybe not for the other ones, but for high performance, you tend to use it when you are on the development phase and testing your materials and proving the case studies, all that steps to go quicker on the market and develop your product in the fastest way. So that's that level. Then high performance, you have to think about if it's high temperature resistance, then you will look at the things around the motor area or all these things around. So that's mainly what you see the incentive in the automotive to use additive manufacturing for the high performance only.
Yeah, I can talk a little bit, expand on that, talk about what I've seen on my end. So when we're talking about automotive, the amount of penetration that AM has had, it has been limited, I think, as Selena said, to a little bit more of the development stage. There are major concerns that, particularly for polymers, that it will provide the performance required to be in tens and thousands of cars without having to have any concerns over like recalls and so on and so forth. And so where have you currently seen it? Aside from prototyping and development, you have seen it in tools, jigs, and fixtures. You're seeing a little bit more of a composite AM in that space, where I think from ID Tech X's perspective, that is the #1 use case right now for composite 3D printing is tools, jigs, and fixtures. So it's done well there. If we go to motorsport, which is not the automotive industry, but related, you see it being used quite liberally for spare parts because it has a turnaround times needed for the motorsport industry. Outside of that, you have seen it on the lower performance requirement end. Like I think Peugeot has printed interior parts using MJF in higher-ish volumes. Having said that, outside of those lower performance requirement spaces like interior parts, your usage of AM for higher performance areas is a bit limited. We did see, I think, spoilers being made by GKN with using MJF, which is like a pandemic precipitated event where they needed all these spoilers. There's no one to do it. And then 3D printing stepped in, which is the right use case for it. But I can't say if that's like a super high performance area. One sort of positive end is that 3D automotive OEMs are continuously looking at 3D printing for the hopes of incorporating them into newer vehicles to improve fuel efficiency, especially true for electric vehicles who are trying to improve the range of their batteries included in the car by using AM for lightweighting. Now, I think that's further on the metal side than what you get on the polymer side. But sort of on the polymer side, there's one commitment, I think, that Cadillac had publicly said they were going to include the most 3D printed parts in their new sedan than any other previous General Motors vehicle. And this came out last year. So like you are seeing further penetration, but the high performance end is really tricky, particularly for polymer AM. Metal AM, a little bit less tricky, but still a very tricky area to gain that trust that it's okay to put in, tens of thousands, maybe even hundreds of thousands of vehicles without causing any issues. Not even mentioning the whole cost issue, the the high cost of scaling up AM. So not even mentioning that. Just talking about a trust and performance end.
Right. Yeah. And there are a lot of issues. Yeah. Even with metal additive in, penetrating the automotive market. So we have about 5 minutes left in this panel, and we're going to see if we can answer a couple more questions. I wanted to, move and kind of stay on this comparison of metal and polymer additive. So I'm wondering if you could, kind of compare for us the different uses for polymer additive compared to metal additive applications in high performance or high technology applications. I mean, can you explain some of the opportunities and risks that there are in using polymer AM versus metal in those areas?
Then I can jump on that question. I mean, definitely the drivers, because let's say the metal in general is there for more than longer than the polymers itself. So it's like also the learning step that people are tending to do. Already in injection molding, you see metal replacement, and most of the thing of that is the driver is like the lightweighting. That's one of the key things. So as one of biggest example, for instance, is for the rocket launchers that you know that the weight in the save that you are doing is definitely something that drives you to go for the polymer switch. That's for it in the medical application as well. Then yes, that's switch when you need to understand what are the key criteria that you need to have, and when you see the performance can do with the polymers and high performance polymer, then you are allowed to do that switch definitely. Now we have seen also that you could also think of, and that's what Polymer is doing, is like also looking at still getting other properties that were in metal that are not in the polymers that can be covered by improving the materials. So that's the main thing that I'm thinking right now.
Yeah, or Paulina, you can go first.
No, I mean, because I don't have any experience with printing of metals, but the main idea why we're using polymers and the polymer composite with the new functionality is that what Celine said, lightweight. So why we want to replace the metals by the polymers, because they are light, so we can save fuel, for example, in the aerospace, and generally we can obtain lightweight, the final product. But also for the polymers, we need to think about the resistance to the thermal conditions in which the polymer will be working, and the thermomechanical properties. So I think it's much more issue that needs to be think about in the case of the polymers. But the main one to obtain lightweight product, I think is the one very motivating for the researchers who's working with that. Yeah, thanks.
Yeah, and sort of just like to hop on that. So when we compare metal to polymer, you're always comparing, metals with high temperature thermoplastics or composite reinforced polymer 3D printing. And in those fields, definitely the resistance in a demanding environment is concerning, because lightweighting would be great, but if whatever you're printing can't withstand the environment that you're typically putting these in, which are generally not like low demanding environments, then that's going to be a major concern. However, on one end, the cost saving that sometimes polymers can add, not just in like the lightweighting of the material, but also and maybe using a little bit less of it. Just generally, sometimes polymers being not quite as expensive as the metal equipment you might need, particularly. That might also drive people to use polymers over metal. But it's very highly application dependent, as always. And I think also just a major concern, again, is that trust. Metals are way more established. And so if you're considering moving to 3D printing, you're probably going to think more to go towards metal 3D printing because it's closer of an analog than your polymer 3D printing, which might be less proven. And so just gaining that ability to make people consider, oh, yes, let's look at maybe polymer, something completely different than metal, which is closer to what we currently know. That's not easy to do, but that's a factor that's driving a lot of people's decisions.
Great, super interesting topic, and I'm definitely learning a lot and gaining some curiosity right now about new polymer technologies. This is the end of our panel today in the technology track. So thank you, Sona, Paulina, and Selena for this super interesting discussion. There's another question here that just came in on 4D printing of materials. If someone has a quick response to how 4D printing of materials is applicable in our daily life. But if not, then I invite you to join the networking session that we'll be going to in the next couple of minutes in the main stage.
I think the quick answer is that it's not really used that much outside of our research academia at this point. Quick answer.
Exactly.
Great. Thank you so much. So thank you again to these wonderful panelists. And please join us for I believe, the next hour on the main stage. You can access that by going to the event map at the top for the networking session. So thanks, everyone, for joining us today.
Thanks as well.
Thank you so much.
Thank you.